Okay, so if I go out and shoot, I'm not a hunter, but I do like shooting. It doesn't really matter. Guns, bow and arrow, Nerf gun, whatever. Slingshot. It's all good stuff, right? So if I go out and I shoot and I put a target up and I take aim, usually it would be with a bow and arrow, because generally you can recover the arrows and you don't have to spend extra money on more shots, right? Because I'm cheap. And let's say that this is my grouping of shots. Would you say that I had a good grouping? Was it pretty tight?
Yes.
Okay. So the grouping's pretty good there. Would you say that I'm a good shot?
No.
I'm off target, aren't I?
That's where you're aiming.
Well, that's true. Now, in this case, I would blame the equipment, of course, right? I would totally blame the equipment. Oh, yeah, there's that. I guess, that doesn't apply if you're indoors. So this is a good grouping, right? It's pretty tight. So what we would say is there's low variability. Low variability, that would be our stats term for that, right? But I wasn't really on target. Presumably I was not aiming for that upper right corner. I was probably aiming for the hole in the middle, but I missed it, right? So I was off target. In stats, we would say that's high bias. I missed it. So, not to be deterred, I put another target up. And I take my shots. Maybe I make some adjustments. Maybe I quit closing my right eye and start shooting with the eye that I should, right? And I get something like this. Maybe I hit the middle. How's my grouping this time? Pretty bad. It's pretty wide, isn't it? Yeah, garbage. Yeah, thanks a lot. Okay. Now, but was I on target? I mean, on average, was I on target? Yeah, in fact, I hit the target once, right? But they're up pretty much around the target, okay? So this would be high variability because they're spread out. But low bias. My grouping isn't so good. That's the high variability. But I was, on average, I was shooting for the middle, and it looks like I was shooting for the middle. So my bias is good. Okay. So I do what any good duffer does, right? Take another shot. This time, maybe I make an adjustment. This time, it looks like this. How's my grouping? Well, this compared to that? Okay, let me throw a few more out there for you. How's that? How's my grouping? Yeah, less good, right? Okay, so my grouping isn't so good, so my variability is pretty high. It's pretty spread out still, so again, high variability again. It would be. It would be high bias because I'm off target, right? High variability and high bias. All right. Now, I'm not really getting better, am I? So I have one target left. And I make some adjustments. Maybe take a few deep breaths, and I start letting the arrows fly, and they look like this. How's my variability this time? Is my grouping good? Pretty good? Low variability, low bias, that's right. Low variability because my grouping is pretty tight. And low bias because I'm on target. So I oftentimes like to give you guys cautionary tales. So here's a very brief cautionary tale. There was a time where I was going around to yard sales and I found some compound bows, and I've never owned a compound bow at that point. I'm like, oh, that'd be cool to have a compound bow. And just so happened that summer I ran across a few for like 10 or 15 bucks a piece. So I got some kids' compound bows, and I got myself a compound bow, and I didn't know anything about it. So we'd go out and we'd shoot like at the school and stuff like that a little bit. Not at the school, we would shoot at the location of the school. Okay? And my daughter said, let's go shooting, and we went to an indoor range at, what is that? I can't think of the name of the place. Oh, it's moved. It wasn't Meridian. Why can't I think of the name? I can like almost see it in their sticker. But anyway, so the bow shop. So we go to the bow shop, and they have this indoor range. And we go down there, Dead On, yeah. So we go into Dead On, and I've got these arrows that I bought like at Walmart, cheap arrows, because I mean an arrow's an arrow, right? As far as I know. So I'm pulling this thing back, and this bow probably had 80 pounds on it. And I was like, I get it back, and I aim it, and the arrow goes off in some weird direction and explodes against something that it's not supposed to even hit, right? I do that a few times. And my kids are like trying to aim at these targets, and it's not going very well for them. So finally I go up. There were probably people going, hey, you might want to get those guys off the range. They're pretty dangerous. I don't know. I'm just guessing. So anyway, so I go up and I say, we're having some issues. Do you guys ever demo bows? Like, oh yeah, we'll demo a bow. So they set up a bow for my kids, and right away they start hitting the target really good. And so the cautionary tale is don't do that, because you will walk out with a much larger debt on your credit card when you walk out with 3 bows. So anyway, however, how it was during the whole Hunger Games thing, and my daughter actually got on TV shooting for the news. So it was pretty cool. I don't know if it was worth the $1,500 that it cost, but it was pretty cool. All right, so let's put this into statistics terms. The target is the parameter. It's the thing that we're aiming at by taking a sample. It's the parameter. And I think a reasonable example of the good grouping, low variability was evidenced in the 2016 presidential stuff, right? They did all these surveys, they surveyed all these people, and everything looked that Hillary Clinton was going to become president, and then that didn't happen. And they're like, what happened? So their variability, I suspect, was quite good. I don't think there was a lot of people answering crazy things, but the bias was high. Now, I haven't really totally researched this, because it's just kind of one of those things where it's like, yeah, they screwed up, and I just go on. But I have some ideas as to why the bias was there and why that happened. I think that because our political system has become so extreme this or extreme that, and nobody can do anything, that the people that were being questioned didn't really want to deal with So for example, in Idaho, Idaho's a very red state. If you run around going, I'm voting for Hillary Clinton in Idaho, there are going to be people that are going to be taking shots at you, right? Arrow shots. Hopefully Nerf gun shots. Really, let's not be too, right? But if you're in San Francisco and you go, hey, I'm all for Trump, make America great again. Yeah, it's not going to go well. And that's unfortunate. I see that as a real problem in our society today because there's no respect for the shoes that people live in and grow up in. And the reality is we all live in our own shoes. And what my ideas are my ideas. It's because of what I've experienced. And what another person's ideas and political spectrum is, or something like that, that's their thing. And it's not right for me to, especially not right to be violent about somebody else's ideas. And the reality is I can never step into the other person's shoes, and they can't step into mine to fully understand. We can just communicate to try to understand. But when there's no communication, there will be no understanding, and then war breaks out, and Nerf. It's time to buy Nerf stock. Okay. Now, so I think that's a good example here. Let's talk about high variability, low bias. I'll be honest, I have a little bit of trouble thinking of a real life situation for this, except maybe, Buddy the Elf, what's your favorite color? If you ask, what's your favorite color, and don't give any guidelines as to what are some potential answers, there are millions of answers that could be given, right? So there's going to be a lot of bias, and maybe you're on target, but there's going to be answers all over the place, right? Okay. So you might be on, but it's probably going to be wildly scattered. Now, high variability, high bias. All right, so I'm going to ask the color question again, but I'm going to say, what if we wanted to know the world's favorite color, but we went to Italy, and instead of saying, what's your favorite color, we said, what's the best color for a car?
Red.
Absolutely. If you're in Italy, you have to have a red car, right? Because Ferraris are red, right? Exactly. And there's going to be some blacks and some silvers and maybe even some whites and stuff like that in there too. But I think there's going to be a high bias and high variability because you're talking about color, first of all, but then it's going to bias off to the red side of things. This is my guess. That's my guess. Okay, you ask an Italian what's their favorite color, red's going to come up more often. Okay? All right, and then low variability, low bias. Here you've asked a good question of a good group, and you have a good grouping of information. So not only does the answer match the parameter, but you end up getting the ability to make a call about what that parameter is. Because here's the deal. We don't know that we've missed the target here. We might know that there's variability here, but we won't know if we're on target here, or even here. But if we do everything we can do to try to make sure that we get low variability and low bias, then we have a good estimator of what the parameter really is. Because oftentimes, in most cases, we can't know what the parameter is, but we can take some steps to try to make sure that our sample matches the parameter as closely as we can. Okay? So if we've done everything we can, this is what we hope for right here. But we may never know if we've actually hit it or not. As in the case of who you're going to vote for in 2016, right? Yeah. Okay. All right. So what that leads us to is the one and only term for today, the unbiased estimator. The unbiased estimator is the mean of the statistic how do we get the mean of the statistic? Well, that's going to be after taking many samples of the same size from the same population. All right, that's how we would get the mean of a statistic, or of the statistic. Is unbiased if it is equal to the parameter being estimated. Question you might ask is, how do you know? You may never know. You may never know. But if you've done everything you can call something an unbiased estimator. I think the key to this is this. This is the key of taking many samples of the same size from the same population. That way, each dot isn't just one individual data point, not like one arrow, but a series of data points. Each one is many, many data points. So let's look at a problem. Number 11 talks about doing homework. Everybody's favorite thing, right? Totally. So, a school newspaper article claims that 60% of the students at a large high school completed their assigned homework last week. Assume the claim is true for the 2,000 students at the school. So 60% did homework. This is a claim by the school newspaper. And the population at the school was 2,000. So those are just some notes to help me remember. It says make a bar graph of the population distribution. Okay, that seems easy enough. Then, if I'm making a bar graph of the population distribution of those that did homework and those that were slackers, if 60% of the 2,000 did their homework, how much is that? 1,200. Good. So my bar is going to come up here to about 1,200. Did the homework. And if 1,200 did the homework, then we have 800 slackers in the group. I will not disclose which group I would have fallen into when I was a high school student. Okay, so we've got about 1,200 and 800. No, I think I can make B fit over here. Let's do that. So B says, imagine one possible SRS of size 100 from the population. So you're taking a simple random sample from the 2,000 of size of 100, and it wants us to sketch a graph of that distribution. Well, if the school newspaper is right, then what this would look like, or should look like, homework and slack, exactly, 60-40. Right? That's what we would expect to see. Now, does that mean that every sample of 100 is going to be exactly 60-40? No, there'll be difference, right? But that's what, if this is true, if we're being told the truth, then that's what we would expect. All right, so number 13 says, some skeptical AP statistics students went to investigate or want to investigate the newspaper's claim in exercise 11. So they chose an SRS of 100 students from the school to interview. So number 13, SRS of 100. And in their sample, only 45 students said that they did their homework. So does this provide convincing evidence that less than 60% of all students at the school completed their assigned homework last week? So what is the evidence? That's A. What is the evidence? Well, wouldn't the evidence be the fact that less than 60 students claim to have done homework? Yeah. So I think that's the evidence. B is kind of interesting, I think. It says, provide two explanations for the evidence described in Part A. Can anybody think of a situation where we would have as few as 45 in the sample say that they did homework when the supposed fact is that 60 should have done it? Can anybody think of an example of when that might have occurred in an SRS? They said it's an SRS, we have to assume that they did that. Yeah, definitely. That's all right. How does a sport event? Oh, I see what you're saying. So because everybody was at the sport event, nobody did the homework? Okay. Sports event? Are you speaking from experience? Or just some, how about a school event? Yeah, Ashley.
Depending on who asked. If the teacher asked if you did your homework,
Ah.
I did my homework, but if you just have a friend ask, you're going to say, no man, I did my homework.
Right, that's true. That's true. If you grew up where I grew up, it was not cool to be smart. You hid that stuff. And I find it one of the greatest differences that I found between kids in California and kids in Idaho is not anything other than here it seems to be cool to be smart. That's a cultural difference that is huge. I like that a lot. Yeah.
It could, like, depending on who you ask, like, what grade they're in, like, because, like, I mean, by freshman, I mean, not
So-
freshman year, it just,
So it should.
senior year might be more school.
It's true. Presumably you'd be looking at 25 of each grade level. But you're right. You could have a higher percentage of underclassmen or something like that. Assuming the underclassmen are the ones that are the slackers. Underclassmen, shall we do / upperclassmen? Okay.
Well, minus kind of going off that with if it's towards the end of the year.
Could be. Yeah, we don't know. I think I want to kind of, we could certainly beat this one dead. It could just be dumb luck. It could just be that sample. It's just dumb luck. Yeah, literally dumb, right. Literally dumb luck. Dumb luck. Could just be that particular sample. So, what was then done, or the next question is, said that they used technology to simulate choosing 250 SRSs of the size of 100 from a population of 2,000. So this is our sampling distribution now, many, many samples. And they use technology. We did that a couple chapters ago, right? Where we did the same kind of thing. And so each one of these dots represents a sample of 100. Did any of them match a 45%? No, none of them. There were a couple that were fairly close. It looks like maybe a 47 and a 48%. But the next closest is 50%. No sampling, no computer sampling went as low as 45%. Now, there is one dot on the graph at 0.73. Explain what this value represents. That dot right there, what does that value represent in terms of probability? Oh, I would definitely, it may not be an outlier, but it's definitely out there. I would say C, that 0.73, represents 1/250th. Oh, gosh, I cannot write today for some reason. I must be getting close to Friday. 1 out of 250. Because it's the only dot that's that high. There's no dot greater than that, and there's no other dots that high. Everything else is less than that. So the probability is 1 out of 250, which is what? Less than 0.5%, right? So your probability is quite low. All right, the next problem, or the next D, I've got to move on to the next page here, asks us, and it introduces kind of a new thing here. It says, would it be surprising to get a sample proportion of p hat equals 0.45? And I'm going to add when p is 0.60. So p hat is something we haven't seen before, but the 0.45 is the sample, and the 0.60 is the claim or the parameter. So the p hat is the proportion of the sample, or sample proportion, and the p is the population proportion, or the claim. Right? It's the claim. So p hat is a sample. It's a statistic value. Would it be surprising to get a sample proportion of 0.45 or smaller in an SRS of size 100 when p equals 60 is what we expect? Would you say that based on this guy right here, would you say that getting a 0.45 or getting 45 out of 100 would be surprising? I think so. It's nowhere near anywhere we expect it, right? In fact, nothing out of 250 trials, nothing went that low. So, yeah, I would say, yeah, duh, it would be very surprising. No value in the sampling. No value in the sampling distribution was that low. emphasis. Okay. And then E, based on your previous answers, is there convincing evidence that less than 60% of all students at the school completed their assigned homework last week? If 60% is what we were told, and 40% is what our sample got, and in our sampling distribution, we didn't even really hardly come close to 45%, is that convincing evidence that the 60% is maybe not accurate? Is it in the bottom or the top 5% of that sampling distribution? It'd be in the bottom, wouldn't it? Yeah. So anytime you're in the top or the bottom 5%, that's going to be convincing evidence. Well, not almost any time. We're heading into detail on that. If you're out over here or you're out over here, that's convincing evidence that that 60 is not true. If you're on the high side, it should be higher. And if you're on the low side, it's convincing evidence that it's lower. Does that mean that it's absolutely incorrect? No. But it does mean that there's convincing evidence that the proportion of students who do the homework is less than 60%. The p-hat value is it's like in the bottom 0% really, right? The bottom 5% of the sampling distribution. So there is convincing evidence. That P equals 60 is too high. It's outside of the norm. It's not, it's outside of what would be expected. So